Okay, so how does this look if we're dealing with limits? Well, again, the first job here is to deal with the partial fraction. So we lift that out of the integral, so we're going to have to keep writing it. Now that one is equivalent to, and you can see here that I have a quadratic factor which is non-reducible. It cannot be simplified any further. So I need an ax plus b above that one, and then I have another linear factor to deal with too. So that's going to be equivalent to ax plus b over that factor plus c over that factor. Combine it. So when I divide the x squared plus 1 in, it's multiplied by x minus 2. And when I divide the x minus 2 in, it's multiplied by x squared plus 1. The denominators are the same, which means the numerators have to be the same. So equivalent numerators. So 2x plus 1 is equivalent to ax plus b, x minus 2 plus c x squared plus 1. It's up to you how you want to choose to do this, whether you want to create the simultaneous equations or whether you want to choose values of x. So if we go for choosing values of x, you will see that if we pick x as 2, that will wipe out all of those and enable us to calculate c. So we'll have 4 plus 1, 5 on the left hand side. That's going to be 0 plus c, lots of 2 squared is 4 plus 1 is 5. So c will take the value 1. If we then let x equal 0, that would be 0. We know c, which will enable us to work out b. So if x is 0, that will, the left hand side will become 1. This side will become b, lots of minus 2. And the c will become 1, because we know c is 1, and that will be 1. Which means, taking that over, I get 0 equals minus 2b, which means b is 0. All I need to do now is choose any value, other value for x, because I only now have one unknown. So if I let x equal 1, the left hand side will become 3. This will become a times 1 minus 2 minus 1 plus c, which I know is 1, lots of 1 squared plus 1, 2. 3 equals minus a plus 2. So a will be minus 1. which means my integral now becomes ax plus b. Well, a is negative, c is positive, so I'll write the c fraction first. So it'll be the integral between 3 and 4 of c, which is 1 over x minus 2, plus ax, so it's minus x, the b term is 0 over x squared plus 1 dx. Now, this is a standard natural log when we integrate it, and this I'm looking, so just like the first and second examples, when I differentiate that, it's going to give me an x, which will cancel with that. So, if for a moment I separate these two integrals out, once you practice these, and hopefully when you were doing your C3 work you did, this is something that you can just write down. You don't have to work through the substitution, but in case you're rusty, I'll do that as a substitution. So if I let u equal x squared plus 1, du dx is 2x, dx is du over 2x. So when I integrate that, what I end up dealing with is x over x squared plus 1 times du over 2x, sorry, x over u. So the x's have cancelled, so I'm integrating that, which is that, and now I'm going to substitute that back in. And the reason that I'm doing that is I'm going to be dealing with the limits of 3 and 4 there, and rather than faffing about changing the limits, I'm going to leave it like that because I've got the same limits on this one. So if I bring this down, this part of it, I can write straight down as the natural log of x minus 2 minus that. So once you're up to speed with your C3 integration, you could probably do away with that little substitution that I've done there, because you'll be recognizing that that is the differential of that, which means you can write it straight down in that form there. But I've gone through that process just in case you're rusty. Okay, so this now we need to put in our limits for. Again, we could tidy that up, but probably it's just as easy not to. So first of all, I'm going to substitute 4 in. So I'm going to have the natural log of 4 take away 2 is 2, minus a half the natural log of 4 squared 16 plus 1 17, minus, and now I'm going to put 3 in, so it's the natural log of 3 minus 2, which is 1, which is going to be 0, minus a half the natural log of 9 squared plus 1, 3 squared, sorry, plus 1, which is 10. So that is 0. So I have ln of 2 minus, ln of the square root of 17, bringing that half to a power, plus ln of the square root of 10 by doing the same thing. So now using the laws of logs, if I'm adding 2, that's the same as multiplying. And then when I'm subtracting, I'm dividing like that. And rationalize the denominator. By multiplying top and bottom by the root 17, giving me the natural log of 2 square root of 170 over 17, which, if I go back to the start, is what they were asking us to derive. Now that one was erroneously or unnecessarily put that in modulus. There's no variable in there. It's quite clearly a positive value, so those are unnecessary, and the brown brackets are absolutely fine.